Quadratics. A quadratic has an x squared as the main term. So for example, y equals ax squared plus bx plus c would be a quadratic. This one we know is a positive quadratic. It's a happy quadratic. That's when a is positive. We're going to look at here when a is negative, we get a sad quadratic, which is a negative quadratic. And we know that because a is negative, a being the coefficient of x squared. Another thing that we can see is c. c is the y-intercept. That's where it crosses the y-axis. So you could read that straight away from your equation. All quadratics are symmetrical and they have maximum or minimum. That is their turning points. Other names for it are vertices, stationary points. Through the turning point, you get a line of symmetry. In most of these quadratics, it's just going to be a straight line, the form x equals, and then whatever the x coordinate of the turning point is. So quadratics are really nice. Something we can use in the quadratic is the discriminant. Now the discriminant is b squared minus 4ac. Might look slightly familiar, that formula. And what the discriminant tells us is if we work out b squared minus 4ac, the a, b and c being the coefficients of x squared, x and the constant term. If it's positive, it cuts the axis twice. If it's 0, it just touches the axis. And if it's negative, it doesn't cross the axis at all. This is all working for a positive quadratic, but it will work exactly the same for a negative quadratic. Crosses the axis twice, just touches it, and doesn't cross it at all. So for the positive one, it tells us we get two distinct roots. That means we get two solutions to our equation. For the equals 0 one, where it just touches the line, that means we get one repeated root. For the negative one, we don't get any real roots. It's a quadratic, so it does have two solutions. They're just imaginary, so we don't need to worry about them. No real roots. We'll look at an example now. Calculate the discriminant of f of x equals 2x squared plus 11x plus 5. Using f of x rather than y doesn't really make any difference to us. F of x just means a function of x, which is what we were doing when we said y equals. State the number of solutions to f of x equals 0. So tell me how many times it crosses the axes. Looking at the discriminant, b squared minus 4ac, so that's going to be 11 squared, because the 11 is the coefficient of x, minus 4 times 2 times 5. 11 squared, we all know, is 121. Take away 4 times 2 times 5, 40. That gives us 81. We know this is positive, so if the discriminant is positive, it tells us there are two distinct solutions. Another example for us now. Find the values of p such that px squared plus 2x plus 1 equals 0 has no real solutions. Whenever it says has no solutions, has repeated solutions, has two distinct solutions, it's saying we need to be using our discriminant. So in this case, we're going to be doing b squared minus 4ac is negative for no solutions. So that tells us 2 squared minus 4p is negative, 4 minus 4p is less than 0. Simple moving it across, 4 is less than 4p, so p is greater than 1. Thank you.